Hello everyone, let's talk about chapter 4, table design and queries. So it's the second class of this topic. And last time I already mentioned about queries and access, right? So SQL, which is a structured query language and is used to create, manipulate, control database object, right? So you can see this actually figure on the right hand and then right side actually, and then here we have a user, right, of the database management system, and user usually send the comment, right, SQL comment to the DBMS so that it can update the data as well as achieve the data, right, from this management service, right, management system. And definitely this system include data part as well as schema and information, right? That's what you call the database. And usually we have 4 queries of the SQL statement. First one is a DDL, so data definition language. Next one is a data manipulation language, and third one is a data control language, and last one is a storage procedure language, SPL. And I will give you an example of these 4 categories and over the in the following slide. And when you run the access particularly, and you need when you run the code queries, SQL queries in language in access, and you can use the SQL view menu, okay, in access, and so that you can run it actually just like this figure. So once you have once you choose the query design and also switch your window like this SQL view, and then you can run the code directly using this window query, okay, query window. And don't worry too much about it right now because we will run multiple statement SQL statement in the following slide. I have so many examples right now, okay. And yes, so let's look at the first example to create, so which is create statement. So we want to create table, okay, or define columns, keys, and indexes. And here is a syntax. Create table, and also you can write down the table name and then column name, data type, which specify the type of the data in a certain column, and the associated constraint, and so on. Okay. Also, if you have a constraint for a certain column, so because certain column can be used a primary key or the foreign key, right? So you can add the constraint using this keyword and then key name, key type, field, and so on. Okay, so let's create a new table called TBL department2 to store the department ID, name, address, phone, and college ID for all departments, right? So here is the SQL statement, and then we will write down this one, okay? So in access, so let's open the access file actually given to you. So if you open the access file, you can see 1, 2, 3, 4, 5, 6, 7 tables here. Okay, and then I developed this one using the Access 2000, and then currently I'm using the Access 365 version. So you may have a different format, but don't worry too much about it because the menu should be quite similar. Okay, so currently we can see the tables, right? And then if you just change the view, just like query, if you select the query, and then you can see the list of queries here. So we don't have any, and let's choose the all access object, so which will include table, queries, and so on. And in order to run your SQL statement, actually you can go to the create menu here and then click the query design as I mentioned earlier, right? So now we have query 1, and this is a design view. You can drag and drop here and select the field name, table name, sort option, and choose the sort option, and so on. However, we will use SQL view, right? We will run the SQL code here. So let's type the create command here, create, okay, and then table should be capital, okay, and then TBL department2, and then open the parenthesis and with this semicolon, but you can actually skip this semicolon if you want it. Also, Yeah, inside of the parenthesis, you can type the depart ID, which will be the first column, okay? And data type is a bar chart. And then constraint for this one is non-null. Okay, so you will have, anyway, you will have a value. This column must have value. And next one is a name. Also data type is bar chart. And if you really hard to read this, okay, command, and definitely, I'm sorry, it's okay to press enter here, okay, and then make a space here, because anyway, access will automatically ignore the empty spaces here. Let me just type like this. This is much better, right? And I have magnifier so that you can see the code better. Magnifier. Okay, let me just use a magnifier here. Okay, so comma, and the third one, name, address, varchar 200. Okay, and then phone, number, call ID, COL ID, okay, COL ID, varchar, data type, and 3 is here. Okay, so last one, let's add a constraint for what? Department. Let's call the primary key, department primary key. So primary key of this table. So primary. So this is a key name, okay, name of the primary key, and type of the primary key, and then type the department ID. Okay. So now I have this code, just like the code shown in your slide. So create table called this name, okay, TBL department 2, and then here is the first column name, the next column name, and third column, fourth column, and the fifth column. And also we add one constraint for this first column, and then this is the name of the constraint. So and then primary key will be, so this column will be the primary key, used as a primary key of this table, and each name will be, property name will be department DPT So once you have this one, let me zoom out. So once you have this code, and then you can click run button, so that you can have what? You can have a second TBL department 2. So let me see the design view of this table. Currently we have nothing here, but so if you double click it, you can see the contents of the department 2, and as you can see, we have department ID, name, address, phone, college ID, right? And also, and you can add the column by clicking this menu, but we are not going to do that. Also, if you choose, if you click the right button of your mouse, and then you can also see the design view, right? So that you can see that, okay, department ID is a short text, which is a bar chart, short text, bar chart, and then this is number. Okay, usually if you just call the number data type, and then it should be a double. Okay, and so you know that the number can be integer, double, long, right? The different types. So if you call number, it should be double. Okay, and the last one is a college ID, short text, bar chart, right? And the size is 3, right? Because we assigned the size. All right, got it? And as you can see, this is marked as what? Primary key here, right? Primary key, right? So we can see that our constraint also appropriately incorporated in this table. Let me close this. Okay. By the way, you shouldn't open any tables when you run the query. Okay, because you want to modify or update or create table, right, using query, then in that case all tables should be closed. Okay, so it's not open, so that's why I didn't open any tables here, right? No tables. So and then you can run this query. Okay, so this is the first example. So now we have this new table called the TBL department 2. And what's the next? Let's look at the slide. All right, let's look at this one. Okay, let's alter table. Okay, and now we are going to change it. Okay, we are going to change the current definition of table. And usually alter statement has this kind of structure. Alter table. Okay, should be capital. Table name, add the column. If you want to add the column, you can use this one. If you want to add the constraint, you can use this one. Also, if you want to drop column, and you can add this one. Also, drop constraint, you can use this command, and then drop table, you can use this command. Got it? So let's do this. Let's do this query. Okay, add a field for the department chairperson to the department table. Okay, so department 2. Okay, and then add a constraint to make a chair's foreign key to the faculty table. Okay, so we will run these two queries in this case. And so previously, let's save the first query as a QRY, create clause. So how can you save it? Go back to your access file, and then you can click the right button of your mouse, and then click save button, and you can type the query name, QRY, create clause. So please follow this instruction, because you will return this access file, and I will check the queries, okay, you have in the file. See, once you create query, and then you can actually see the new query under this queries menu here. And close it. Let's create another query. Let's click the query design. So now you can create the new query, and also when you click the right button of your mouse in this subject, title, view, and then you can choose SQL view as well. This is another way to see the SQL view. All right, so let's add a field. Okay, alter table. TBL, name of table is a TBL department 2. Okay, and you can make a space if you want it. Add column, chair. So this is name of the column name, and this is the column name, and then data type is long. Okay, another one type of the number type, one of data type in number, right? In number category. So if you run it, so let's run it first. And then now you have another column. Let me open this one. Another column called the chair here, right? Now we have this one, right? Close it. And save this one as a what? Save this one as a QRY, alter clause 1. And let me close it, and let's create another query. All right, so alter table TBL department 2, right? We want to add the constraint right now. Add constraint the PT foreign key, second, foreign, EIGNKEY, foreign key, and name of the column will be chair. And reference, because this is a foreign key, so we need a reference, right? References TBL faculty. So we are getting the information from the faculty ID column in TBL faculty table. Okay, so here, run it. So it runs. it ran successfully. Let me save this one as a QRY alter clouds 2. Good. So let's look at this one, table 2. In design view, you can see that this new code one, right? The chair, right? Number as a number, right? We add one column here, and then also make this one as a what? As a foreign key. So connect it to the faculty table. Let me open this one. Faculty table, right? Faculty table having what? Faculty ID. So this is a faculty ID, primary key, right? And then faculty ID, right? So here, so let's check the relationship between these two tables. So here's a relationship menu under the database tool. And if you just add the table 2 as well as faculty, and you can see the relationship between faculty ID and chair here, right? One to many. So now you know that this one is used as a foreign key, right? In this table. Got it? If you didn't add the constraint, and then you cannot see the link between these two, faculty table and as well as table TBL department 2. Okay, so let me remove these two and then close it. Nope, I'm not going to save it. All right, good. Yes, let's run the another option here. So I already mentioned the alter statement, and alter statement, we ran the 2 alter statements here, and then let's remove the database object. Okay, so let's remove the database object in drop table using this drop table command here, and so we will remove table TBL department 2, okay, in drop using this drop table command. So let me go back to the access, then create the new query, right, and then see the SQL view and type the drop table TBL department 2. Department 2, yes. And you can put the semicolon, or you can just run the code like this. Run it. So now we don't have the department 2, right? And let's save this one as a QRY drop clouds. So we just generate the fourth one, right? Drop clouds. Okay. So once you have this kind of queries, and then you can run it, right? Let me just run this one. You can run the code, okay? If you double click it, yes. And then now you can create the table 2 if you just run this. If you double click it, and then now you can run the this SQL. So I just deleted the TBL department 2, right? Again. Okay. All right. If you run the code, these two code right now, and then definitely you will get an error because we don't have any table called the department TBL department 2. Okay. Let me go back here. So let's talk about another statement, select. And project selected table, okay, field as query output. So select, this is command and field name from table name, right? So project show the student name, email, address, phone. Oh, basically I need to fix this one. Date of birth field from student table. Okay, so we will run this code. Let me just fix the typo, sorry. It's your name, date of birth. All right. So let me choose access file and then create. Now you're familiar with it, right? Create query design and SQL view, right? So that we can type the select name, email, address, date of birth, from where, TBL, student, right? This is a table of the student. Let me just open this one, right? So we have a student ID, name, so department ID, name, class, type, email, address, date of birth, and also gender, right? So let me close this one. So you can run this code right now. So if under the design view, you can run this code, right? So run it. So if you run it, and then definitely you can see the result here. This is a result of the query, and definitely we from the student table, we got the name, email, address, date of birth only. Okay. So here, if you go back to the SQL view, this is the datasheet view. So if you go back to the SQL view, you can see the original command here, and definitely we will save this one as QRY select clouds 1. Okay, and close it. And next one, let's join the table. So get the data from the multiple tables. So join table in SQL using from clouds. So the query is select the constraint information and contact information and the department name of the individual faculty members. So we have the first name, last name, and this is the name of the department, and also address. So and then from the faculty table as well as department table. Okay. So let's go back to the access, and then what? Create query design and SQL view and type the comment. Select first name, last name, address. So let's check the design, okay? Design of the faculty folder, so design view. So as you can see, faculty table has a first name, last name, joining date, phone, salary, URL designation, right? So department ID as well, faculty ID. So as you can see, you cannot find any name here, and address is not here, right? So that's why. So you shouldn't use the same name, okay, from here and there. So from the another like the database here. So here is where department, right? Design view. Design view is slightly different. Design view, you can see the name and address, right? Also phone number here, right? And close it. Let me close this. Okay, so from TBL faculty, TBL department. So these are the names of two tables, right? And run it. Under design, run it. So now you can get the name, first name, last name, and then department name, as well as the department address here, right? So from the database. Very easy. So that's why you should know about the SQL language if you want to really if you want to analyze the big data or manage the big data. Okay, that's why I ask you to take this course, right? If you want to become a big data analyst. Okay, analyst. So SQL view, and we need to save this one, right? Query, select clouds 2. Let me go back, to the slide, and then now what should we have? Let me just close this one, magnifier. So because your vision is very good, right? So you can see you can read the small characters, right? So you guys are not like me, so you can read it. I believe that. All right. So as clause rename. So renames database object useful for referral tables or columns in case of name conflict. Okay. So select the contact information and department name of the individual faculty member. As I mentioned earlier, if two table has the same name, and then definitely the program may have the confliction and cause error message. So that's why I ask you to use a different name. Is it possible? But if both table has the same name, and definitely you need to have this kind of statement. All right. So faculty dot department dot here. So let's use this one. Okay, statement in Access. You may wonder what I'm talking about, right? Let's go back to the department view as well as a faculty view. All right. So here, if you just get the phone, right, from two table, and then definitely you will have a error because both names are same, right, in two tables. So computer doesn't know which data you are asking for. So let me see. So create the design, query design, and query SQL view. So let me just choose. First of all, let me type this one. First name. So previously we have this statement, right? Last name, and name, address. What about phone? So we will have an error, right? Because this phone information, so the both table has a form column with different information, right? TBL, department. Let me run it. See, the special field phone could refer to more than one table listed in the from clause of your SQL statement. That's why. Okay. So let's modify it. Okay, as I mentioned earlier, using as clause. So first of all, you need to type the fact dot last name, first name, last name, and then also the let me just remove this one. Fact. And then now is a department. The T address. Well, we can keep the name actually. Department name and department font. Okay. From where? From TBL faculty, and the S, we will call this one as a FAC. Okay, so how, that's why we just use FAC instead of the faculty, TBL faculty here. Okay, and then also it's more like a nickname. This one FAC is a nickname of this table, and also as what we will call this department table will be as a DPT. Okay, all right, so that's why we are using this one here. If you want it, you can change each nickname like a DE or and so on, right? Then you need to modify this one, right? But anyway, let me run it. See, now you can get the correct table, right? From the without having an error message. All right. So let me go back to SQL view and save this one as what? Save one as well as QRY as clause. Okay, close it. Yay. So we completed 7 examples. Where clause equate primary key and foreign key. Okay, and then select the contact information and department name of the individual faculty members. So we will run this code here. So let's open the access file. Go back to the access file. So create query design and SQL view here, right? So that we can type the command here. Select, oops, and faculty, first name, faculty, last name, DPT, address, EPT name, from table faculty as FAC, right? And then TBL department as EPT, right? Where, okay, where faculty department ID should be equal to what? You should use the key name, right? DPT. Column name here, so department ID. I'm sorry, yeah, column name. So because if you go back to the faculty and this table, let me see the design view. So we have the department ID. Definitely, this is a primary key for this department table, and then foreign key, right? Foreign key. Department ID is a foreign key, right? Of this table. So that's why you should find the information, because previously we just collect all the information, right? And then there should be redundant information. However, we want to make sure that this faculty ID should be equal to the department ID so that you can get the correct information. Okay. So this is a condition. Where is the where keyword clause is used to give the for the inner join. So we will create the table. Okay. And let me say this one first. So QRY where clause 1. Okay. Then let me run it. Design run. So now you can see this information. Okay. Here very low, so we can see the one person in each line, right? So there is no redundant members. Okay. And as you can see, so just it has the same in the same department, right? Let me go back to the SQL view. So this is an example of the where clause. And let's do the next one. So you also put the criteria, right? So here for your search, so select from and where, and then you can put the criteria here. Okay, let's select the contact information for the faculty members who joined the university after 1995, and then salary exceed $75,000. Quite a lot, right? It seems like it should be the assistant professor level. Okay, so anyway, in tenure track. Okay, so right, so this is like this. And definitely we can go back to the access, right? So let's type the new query. So let me close this one. Then create the new one. So query view, SQL view, and select first name, last name, because we are using just getting the information from the one table, so you don't have to specify, you don't have to use as keyword clause here. From which table? Faculty, right? Because we want to get the faculty information, right? Having a salary greater than exceed $75,000. And where? So salary should be $75,000. So let's look at this faculty table. In design view. So here we have salary category, right? So all information should have the same unit, by the way. And design view, salary, right? Also, we will check the joining date here, joining date, right? So it's a date and time, right? It's a type, it's a time. So, and because we have two conditions, so joining date, they must be same, okay? 2000. The format also should be same. So 31 2095, right? December 31st. Got it. Okay, let me save this one as a query where clause 2. Good. So let me run it. So now you got the employee, basically the faculty members under the given condition, right? Joined the university after 1995 and salary exceeds $75,000. So these are the faculties. So if you look at the original faculty table, and then there should be, oh yeah, there are many faculties, but we only have this many. Okay. Okay. Close it. Let's do the one more thing. So query, select the contact information, department name for faculty members who joined the university after 1995 and salary exceeds $75,000. Okay, let me go back to Access, create query design, SQL view, and type the query. So select faculty, because nowadays we need two tables, so I will use as clause here, FAC, last name, I'm sorry, name, department, address, and department, phone. By the way, if you use a different database system, and definitely SQL, the structure of the SQL can be slightly different, okay, in terms of syntax. So when you use a Python, the syntax between the Python and Java program is slightly different, right? So the same thing happens according to your database management system. So MySQL or Access, right? They are different department slightly. EPT. All right. So this is really hard to read it, right? From table where faculty department ID equal to DPT ID, and what, salary should be greater than $75,000, and joining date. Ooh, yes, the 31st December 31st, 1995. All right, and run it. So joining date. Oh, there was typo. Cancel. Yes, I'm sorry. Yeah, run it. What's happening? Okay, let me see. Oh, joining date. And I didn't type FAC. And design running. Oh, sorry, should be greater than running. So now we can get the answer. See, so I made a mistake. So go back to here, and then you can save this one, and save as a, oops. If you, yes, let me just change the name of this one. Rename. Oops. Rename. So close it, and then if you type rename, and then you can rename it as query where clause 3. Okay. Operators. Expressions in where clause can include these three types of operators: equal, less than, greater than, less than, equal to, greater than, equal to, and also and clauses between, like, in, logical operators, and or not. Okay, we already actually used the and in the and operator in the previous example, right? So let's look at the between clause. You can actually, it can be used with the logical operator and to specify range of values. and here and then here we want to select the contact information and department name for faculty members whose salary is between 25,000, 65,000 and 75,000. Yeah, I missed the comma here, so let me fix it a little bit. Yeah, and also dollar sign. And you don't have to worry about the dollar sign, but yeah, so the money. So that's why I need to include the dollar sign here. So we will run this query actually. So let me go back to the access here. So let's create the SQL query design and select the SQL view. All right, and then let's type what? Select faculty first name, faculty last name, department, address, department, phone, yeah, and department name, from table name, faculty as what? FAC. So we will call this table department as what? DPT, right? And where? So faculty department ID equals to DPT ID and salary between 65,000 and 75,000. Yes, we have this one here, right? And if you want it, also you can use the faculty salary. Actually, both are things. All right, so let me run this one so that I have employees, actually faculties, having a salary between $65,000 and $75,000. All right, and then here is the address of the department and phone number of the department, and department name is here, right? So okay, now let me just go back to the query SQL view and save this one as what? QRY between clouds. Okay, all right, let me go back to the slide. So like clause is used in search criteria and with wildcard characters. So these are the wildcard characters, okay? Asterisk and question mark. So query, so we want to list the contact information for all ISC, industrial systems engineering students who have taken computer or database related courses, like this course, okay? All right, so we will run this really lengthy SQL statement here, and then let's type it. Okay, you can actually copy and paste this one actually from your slide, but let me type it. Okay, right. So that's all. That's the easiest way actually to remember the SQL language. So please type the entire language by yourself instead of the copy and paste it. Once you're familiar with it, yes, you can copy and paste just the SQL query, right? So let's use the select, and T1 will be the nickname of the what? Should be nickname of the student table, right? So name, T1, email, T1, addresses, T1, date of birth, from. So you can actually type the from here, or if you don't like it, you can type from here. So because anyway, query will ignore the space. So you don't have to worry about the line, okay? So student, this table, right? This table, and as T1 and TBL, transcript, we have also transcript. Which one is this one? Okay, this table. TLB transcript as T2. What about 3? So TBL section. So we have section information here, right? Section as T3 and TBL course. We have course information as T4, right? Let's look at the section here. So if you double click it, and then you can see the contents. Okay, evaluation, capacity of the class. So each class, right? Section number, and course ID, faculty ID, so and so on. Let me just look at this one using design view, right? And year, semester, capacity, evaluation. What about transcript? Design view of the transcript, section ID, student ID, grade, right? If you just look at this one in datasheet view here, and then you can see the ID, student, and grade. Okay, so it's a GPA actually of the each student. And let me close these two tables. What about the new one? The course. Also, we have the table called this course table, having information about each course credit, because certain course can have multiple sections, right? So that's why we have separate two tables here. Visual Basic, Advanced 13, and so on, data structures, right? And so on. So let me close this one. All right, so T4, and where, we need to tap where here, and T1, student ID, it has the student information, right? And the T2, and student ID. So as I mentioned before, before transcript table also has a student ID, right? Student ID. And then, and for certain student, you can get the information. Section ID equal to T3 section ID, right? So that we can get the relevant information. What about T3? T3 course ID equal to T4 dot course ID. And yes, T1 DPT permanent ID is what? Should be ISE, because we want to get the information about about the student in the what program, industrial and systems engineering program, right? And so T4 dot name like, so like is a similar, so we will get the course name having computer, either computer or database. Okay, T4 dot name like one name, aesthetic, and then put the aesthetic before the database, after the database. Okay, right? So this is a very lengthy SQL. All right, and then let me run it. So design, and you can run it so that you can get the student information, having the courses before, right? Having the course related to computer, or either computer or database, right? Let me see this one in SQL view and save this query, right? The query as a query QRY like clause. Right, so we have this one here. Let me close it. That's how you can use the like clause in SQL. And sometimes if you go to the US, actually, sometimes some students actually read this one SQL as a SQL or SQL, something like that. Okay, so but let's use the original, actually pronunciation should be SQL. So here in clause, makes in clause actually makes a selection from data set, and we want to list the contact information for all distinct ISE students, so who have taken computer or database related courses. So distinct ISE student. So here we will select the distinct student ID from this transcript. Where transcript? Okay, from the transcript. This student is a kind of the excellent student, right? All right. Let's go back to this access and then create new query. Yes. Making another one. SQL view. In SQL view, let's type this. Select name, email. You may notice that we will use one database here, right? DOB. From table, student table. I'm sorry, student table. Where depart ID equal ISE and student ID in select distinct student ID from TBL transcript where section ID in, yeah, so you can have this one as well. Select section ID, I'm sorry, no space, ID from TBL section where course ID in select course ID from, let me change the line, from TBL course where so we have 4 parentheses. Yeah, you should be careful about the number of parentheses here. All right, where name like what? Computer, right? Aesthetic computer here or name like database. So if you look at it initially, we will get some information, course ID, from this course table, right? Having these two keywords, right? And then, so, and then, and in, from that, you can get the course ID, right? So anyway, you can get the course ID, right? From there, from TBL section, you will get the relevant information, right? So relevant section ID. And also from this transcript, you will get relevant student ID, right? So in order to do that, we use in keyword, right? Clause here and there. Also here. Right, let me run it. Oops, error, maybe I missed something. Select a name, address, DB from student where deep in IC, okay, and then student ID in select distinct student ID, it should be from PBL to run script where section ID, no space, I'm sorry, section ID. So now we got the information. Yeah. Yeah, be careful about your, the typo in your sentence. Let me just save this one as a query. So here we save this one and with as a query QRY in clouds here. Okay, so you can save it. So here I have one. What else do we have? We have also, you can sort the data, okay, and using in SQL, and in order to sort the record, ascending order or descending order, and definitely you can actually use this keyword here, comment the clouds here, order by, and field name, ascending, descending, okay, so you can choose one of them. Don't type, do not type both at the same time. All right, so here is a question. So we want to select the contact information and department name for faculty members whose salary is between 65,000, 75,000. List the, I missed the dollars here, and list the output first and in ascending order of their joining date, and then in descending order of salary. So we will type this query. So joining date, ascending order, salary, descending order. Yes, you can use these two, okay? All right, let's go back to access, the access here, and then create new query. And then SQL view, right? All right, type select, FAC, first name, and FAC, last name. So in this case, we will use two tables, okay? Department, address, department, phone, and department, name. From where? From table, faculty, as FAC, also table, department, as DPT, where FAC, DPT, ID, DPT, DPT, ID, and salary between 65,000 and 75,000. Yes, and then order by what? Joining date. Joining date in ascending order, and salary in descending order. So let me run this one. Okay. So we already sort the data. Okay. First, we order the people, actually faculties, in ascending order of the joining date, and then in a descending order of salary, right? So let's look at the faculty table here. You can check, right? So we have Joe's. Where is Joe's? So Joe's. No, not this Joe's. Joe's. Yes, here we have joining date. This person joining date of this person is 1977, February 9th. What about next person? Dallas. Dallas. Where is Dallas? Yes. So this is 1984, March 8th, right? So the ascending order, right? This is a small date. The joining date of this one is earlier than the next person. right? That's ascending order, right? So the number will become larger and larger and larger over people, right? And also if, and then what about Miguel, Recono, Miguel, where is Miguel? Miguel. Okay, let's just get the, let me go back to the SQL view and then yeah, let's look at their joining date. FAC joining date. If you want it, you can actually add the additional information, right? So faculty has a what? Salary. So I just add two more columns here. Let me run it. So joining date, see, this number becomes a larger and larger and larger, right? And if joining date is the same, and then this value is getting smaller, but you know, technically this not affect in this case, since all people joining date of the all people are different, so that's why we cannot find actually the similarity here. So let me fix it a little bit. Here, order by salary. What about this? Okay, let me run it. So here, you know, unlike a previous example, now you can see that, okay, the members are actually faculties are sorted based on the descending order, right, of salary. So this number is getting smaller, right? Let me go back. Let me fix this one and then save it. Order by joining date, ascending, and salary, and then let me just keep this one. Save this one as a what? QRY, order by clause. Oops, there was a typo, it seems like. Joining date, I'm sorry. So save it, rerun it, okay, good. So be careful about the typo, okay. All right, close it, close it. And let me go back to slide here. Built-in functions, min, max, sum, average, count. So we have several built-in functions, and these five are most popular built-in functions in SQL. So if you choose a mean, you don't have to recalculate actually the mean value, minimum value, or maximum value, or summation, or average of certain category, right? All the values. Or you don't have to even count the number of records in the data set. You can just use this function basically, built-in function. Syntax, function name, fill the name as a, if you want to rename it, and then you can use add as clause here, and with group by clause. So here, let's look at the example. Good. So here we have, we will use the group by clause in addition to the built-in function. So here is a group by after the where, right? So we will count the number of students for each department in the department table. Great. So let's execute this clause here. So let me go back to let me go back to this access. So create query design and SQL view. And select department name and count. This is a built-in function, right? Count. We will calculate the student number here. Student ID, technically, student ID from the student table, right? So here, and as total student. So we will calculate, so basically we will generate a new category and column called known as total student, and then that column will have the information about the total number of students, right? In this, using this function, right? And let's type the additional information here from TBL student as what? As TD, right? That's a nickname of this table. TBL department as DPT, nickname of the department, and where std dot department id equals to what? Department id, right? Should be in the department table, right? And then group by department name. So because in each department we want to know the number of students, right? So that's why run it. See, in this department we have 114 students, and in this department we have 92. In this one we have 116. In this department we have 88. In this department we have 90. Got it? Let's go here. That's how you use count as well as group by. So that's why you don't need to see the multiple relate the rows having the redundant information here. Right. Let me save this one as well. QRY group by clouds. Right. Let me close this. Next one, having clause. It is used with group by to specify criteria on group values, and syntax is like this. So after the group by, you can add having here, so that you can address the criteria on this group. Okay, so let's look at this example. You want to reach the departments in the College of Engineering that have total enrollment exceeding 100 students. So it's more like big department. Okay, we want to find the big department having students exceeding greater than 100 students. So here is an example code, and we will type it. Let's type it. Query design, SQL view. Here, select department name, count, and std is a nickname of student table as what? Total student from what? TBL as student as what? std TBL department as dpt, right? Where std dpt id dpt id and dpt college id coe. Group by department name having count std std student id like this, right? And running. So we have only one department having this condition, right? You remember the previous clause? What was it? Let me compare this one with the group by clause here. If I double click it and see that, oh, this is the older by, sorry. Group by, yes, here. Because you realize that we have we have this computer information science engineering department as well as, and also this pub. Oh yeah, that's right. Yes, that's interesting. Yeah, it's because I add one more condition here, so College of Engineering. So that's why. But if you just remove this condition, and you will have a two department, right? Like this, right? So that's why. Yes. All right. Let me run it. Oops. Why? So we have department having a student greater than 100 here and there, and now you can have two departments basically. So let me go back to code. If you add this condition, and then you can see the one college engineering, technically college engineering, right? So department in the college engineering. So this is not college engineering, right? The one, this is not the department at the College of Engineering. So that's why we ignore this one. So right now you have only one result here, right? Closed. No, let me save it. Right, I'm sorry. And let me save this one. So query having clouds. Okay, and here's a tip for you. So basically, when you use a select from clause, and then you can type these two first, and then you can actually sequentially type the where group by having order by options like this. Okay, optional must appearing in this order, so should follow this order. Okay, and if you don't like to, if you don't want to specify the some information category using where group by having order by, and then you can only use these two. Okay, select certain column from which table, or right, so like that. All right, so insert statement. We can insert one or multiple record actually into a table. Right, so data into a table basically. Query, so we in this example, so this is a syntax of the insert query. Insert into where, so insert into table name and column, right? Also the value for each column, right? So we need to address all columns as well as all values here. So insert information about the new department. So let's say we want to make one new department here, and known as a digital institute, into a department table. So we will use this, run this query. Okay, so as you can see, we have department ID on DGI, and the name is a digital institute, address is a 303 FAB, so it's the building name, and address is here. Oh, I'm sorry, this is the address, so building name and stream name, and then the UFL, University of Florida, I guess, and then this is a zip code, right? And the phone number, and here, and the college ID is a CFA. Okay, so 1, 2, 3, 4, 5 columns. So this table we have 5 columns, and then we need the 5 values. Got it? Yes. So let's do this. Let's go back to the access, create, query, and SQL view. Now you know what to do, right? So type insert into DBL department and department ID, name, address. So this name should be same as a table column, the column names of the columns in the table. Okay, college ID. If you are not sure about it, and definitely you can open this table and then see the design. So department ID, college ID is here, and name is here, address is here, and the phone here. So it should, so sequence doesn't matter, but make sure that you have all values here. Okay, and values, let me just change the line here. So values, and first one is a character, right? DGI, and then next one also is a character. Data type is character. So digital institute, and then also address is a character, I guess 303 FAB UFL 32611, and phone number 3921044, and last one CFA. Right, let's run it. So here, before I run this one, let's look at the table. Okay, here we don't have any department called Digital Institute. So let me close it before I run this code. And then here, design, let me save this one first. So query insert, okay, and run it. Yes, so that's a warning message. So now let's open this department. Now we have a new department called the Digital Institute here, right? Good. Yes. And close this one. Let me go back to the slide. Update. Update statement. So you can actually update one or more rows of table using SQL. And here's the syntax: update, set, and column value on where with the criteria. So here is a query. So we want to raise the salary field in the faculty table by 5% for all faculty members who joined the university before 1995 and earn less than $70,000. Okay, 5% increase the salary by 5%. That's good news, right? All right. So how can you do that? Yeah, you can multiply 1.05. So this is a 5%, right? And multiply this value by salary so that you can get the new salary. So here we can create a new query here. So create query design and SQL view. Type what? Update TBL faculty, right? Set salary equal to salary equals salary 1.05, right? Where, so that you can give the condition, right? Joining date should be less than, right? Less than 5 year, and salary is less than $70,000. So earlier than this year, right? Okay. Before we run it, let's look at the salary. Let's look at the person actually joined the university before this, 1995. So this person, first person, okay, salary is 81,089. Okay, 81,089. 81,009. Let me run it. Let me just delete this one. And reopen it. Oh, so this person is too high. I'm sorry. So let's look at the person who joined the university and then having a really few actually less salary here. So 5A776.90. Remember this, right? And then when we run it and close the table and then run this query, we open it. So 5A, which person was it? All right. Oh, yes. 5A776.90, right? So that's a value. You update information here, right? So previously, what was it? 5A776.90. So let me just change the info, like salary, increase the salary to 80,000 so that we can easily identify who actually got the new salary here. So 80,000 will be the new salary. Okay. Oh, it's kind of hard to remember it. All right. So 80,000. Let's look at the 80,000. What's the problem? Zero row. So condition is wrong then. So here, let me just check the condition here. So 70,000 salary. So let's look at the ideal candidate here. Okay, 5 TBL faculty, set salary 80,000, and then here the 70,000 less than faculty. Okay, salary, and then joining date. No typo, right? Joining date and less than. What about 2,000? Earlier than 2,000. Let me run it. No. Numerical format. So yes, you are about to have update 15 rows. Yeah, data type was the issue. So here, if you click yes, and definitely you will have a bunch of people having the $80,000 like this, right? So, right, and then here also you can increase the salary by 5%, so 1.05 here. Okay, and then let me just change this one to the 1995 so that you can actually conduct the right command. So here, no. So joining date was what? Almost 2000. Also, because nowadays they have 80,000. What about 90,000? So here, Yes, we have 23 rows, and then you can update the salary by 5%. And let me look at it. So he was so there was a person having 80,000, and then now you can see the 5% increment. Right. So here. Okay. So that's how you actually handle this set and update uh, query, and it's a kind of tricky to see the actual update, but now we solve the issue, so you can actually use this query and save this query as well. QRY, QRY. So what was it? Insert? No. Insert. Actually, update set. What was the appropriate name of this? Update. 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 Right. Okay, and close this. Phew. Yes. And there was a typo in our slide, right? And here 0101 73. Yes, good. And here, if you want it, and let me just use a parenthesis here and there. Right. Okay, so let's move. Okay, and here is a delete statement in order to update the one or more rows of table. Yeah, technically, yeah, it's a kind of update, but let's type the delete. Okay, right, query, delete record from the student table and the student in their last year of the engineering, i.e. engineering. Okay, last year. So delete everything from which table name, and then this is a condition. So let's run this one. Help create create query and SQL view. Type delete everything from TBL student and where class equals to what? Senior. So last year, right? Last year student is known as senior student, right? And department ID ISE. So we will not find any senior student in the at the ISE department. So here, if you look at it, we have a student, right? And senior students, right? And ISE industrial engineering is here. This is a sophomore, freshman, junior. What's the ISE senior here? Where is it? Industrial engineer senior. Oh, here. Lynette. Okay. And Elderman. Okay. And here. So 1977. 1977. Lynette Elderman. Try to remember this. Okay. All right. I'm running. 18 rows. So we will remove the 18 students from the record. And then now, as you can see, you cannot find any senior students from the industrial engineering. If you want to check correctly, definitely you can create another query, right? Select everything from what? Student, where, class, senior, and department ID. So we will have 0 record, right, on this. No record, right? Because we deleted. So that's why. Anyway, let's save this one. Delete as a query delete. QRY delete. That's how you delete multiple record from the table. Okay. Whew. So this is the end of today, and now we will have about how many queries we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Wow. So please open your access file to the class so that I can actually give you the point. Thank you.